How is it that looking through a telescope, you see thousands more stars than with just the naked eye? There are two possible answers. 1. As commonly believed, the additional stars are light years away. At their great distances, the light from the stars is not at a sufficient level for our eye to see. A telescope can only make the additional stars visible by increasing the level of light to the individual rods and cones of our eye. Magnification will make very little difference, as their angular size is extremely small. 2. The stars are closer and smaller. Their angular size is too small for our eyes to resolve. With magnification, their angular size increases and makes them visible. Can this telescope make a star that's 6 times too dim or more visible? There are two types of telescopes: a refractor that uses a lens to gather light, and a reflector scope that uses a mirror. The light-gathering power of a scope is determined by the diameter of this objective lens, compared to the pupil of the human eye, at 7 mm. A 130 mm lens, divided by 7 mm, then squared, gives us a light-gathering power of 345 times more than our eye. Magnification is the fixed focal length of the scope, divided by the focal length of the interchangeable eyepiece. The Astro Master 130 EQ has a focal length of 650 mm. With the 10 mm focal length eyepiece, it's 65 times magnification. With the 20 mm, it will be 32.5 times. Looking through a telescope, a usable image is a balance of the light-gathering power of the telescope and the amount of magnification used. A dim object with a small angular size takes up a small area of the retina. If we magnify the object without increasing the amount of light, the angular size will increase. The individual rods and cones receive less light, so the image will be larger but dimmer. With the additional light being gathered by the main lens, it becomes brighter. With 345 times the light-gathering power of the eye, magnifying the object 18.5 times will get the equivalent brightness as the naked eye. Each of the rods and cones will receive the same amount of light. This is because the light is projected over 345 times the area, equaling the 345 times light that is gathered. Increasing magnification beyond 18.5 times reduces the amount of light hitting the rods and cones, creating a dimmer but larger image. The only way to make a very dim object brighter is to reduce the magnification below 18.5 times. This increases the light level to the individual rods and cones of our eye, creating a smaller but brighter image. The torchlight represents the light from the distant object, amplified 345 times. When projected onto the wall or retina of our eye, the area of the light is equivalent to 345 times in area than the light in the distance. Both lights are the same brightness, one is larger, as it would be when magnified onto your retina. With greater magnification, the available light covers a larger area, getting dimmer the more you magnify. The only way to make a dim object visible is to magnify below the equal brightness threshold. The problem is, with a standard size eyepiece, no telescopes do this. For different aperture sizes, the equal brightness magnification is simply the square root of the light-gathering power. To be visible, this star needs to be 6 times brighter. Using this telescope, at 18.6 times magnification, we have equal light to the individual rods and cones of the eye. There is no increase in brightness, yet we see more stars. Using the 20mm eyepiece with 32.5 times magnification, the light becomes dimmer. And at 65 times magnification, the light to the rods and cones of our eye is 12 times dimmer. Using a telescope with 345 times more light-gathering power than your eye lets you magnify an image 18.6 times without losing brightness. But here's the catch. If you magnify beyond 18.6 times, stars start to dim. A star just bright enough to see at 18.6 times magnification will fade from view at higher powers. Beyond this, the telescope is only magnifying, it's not making things brighter. Importantly, a star that's 6 times too dim to see with the naked eye will remain invisible. Yet we see more celestial objects, including colors. As you move away from this 500 million lux lighthouse, the light dims according to the inverse square law of light. When its light just becomes invisible to the human eye, it would be impossible for this telescope to make it visible. The stars must be closer and smaller.